Okay, so on example 2 and 3, I went ahead and wrote down the limit properties for each of the problems, and then we'll just pick it up from there. All right, so on A, let's go blue. On A, it's going to be the square root, and notice I've inserted the limit as x approaches c to both of the h and x and g of x. Okay, so we're going to have the square root. I didn't go blue. 3, and then they told me what the limit as x approaches c of h of x is. That's up here, it's 4. So that's 4 minus 2 times, try that again, 2 times, and then the limit as x approaches c of g of x, we are told is negative 2. So we just have to pick it up from here. Yeah. All right, so here we go. So this is going to be the square root of 12 plus 4, which is square root of 16. And then thank you very much. That's 4. Okay, so that's how these are working. And so I'll just continue. Honestly, if you don't want to write down the actual notation there that I started off with, that's okay, because I think you got a feel for what's happening. All right, now if you want your notes to look exactly like this, then you can, but I'm not going to require it because it's a bit of a pain. All right, so on this one, it's like you're distributing, but you're not really. I'm just assigning the property here where these two multiplied together could be the product of the limits rather than the limit of the product. All right, so all right, and then the constant multiple, I just left it alone. You won't assign 1 to that. Okay, so the limit as x approaches c of f of x is 3. This is exactly how you think this should go. And then 5 was just a constant multiple. And then g is back again at negative 2. And so what I got, negative 15, 15 times negative 2. And there we go. Yay. All right, down here, we have several things happening. I like this a lot. So once I assign this limit to the 7, because that's not a constant multiple, that's just a constant. So that means that is going to stay 7 regardless of what x is approaching, minus, and then the g of x, x approaching c of g of x, is that negative 2? Yeah, that's negative 2. All right. And then I'm squaring that entire result. Okay, so I've got 9 squared, 81. All right, this one looks insane, but you're just using the limit property 4 times across here with these constant multiples out front. All right, so this is using all 3 of the functions they gave you. Let's see if I can find room for this. So this is 2, and the f of x was, what, 3? Pretty sure. All right, plus 3 times, and the h of x was 4. And in the denominator, we had the h of x again as 4, that limit as x approaches c, minus, and the g was negative 2. So we got some work to do there, but we'll clean that up. So up top, I have a 6 and a 12. True. And in the denominator, I have a 6. And that simplifies to 3. Okay, so that one worked out pretty good. All right. On the next one, we have a product of one single limit and then the sum of 2. All right, so see what I did? I left that one on the outside just fine, but then on the inside of this parentheses, we have the limit assigned to that and then another constant. So the constant, that's a weird place to start, but I went ahead. That's just 6, right? There's nothing to change it from 6. And then the f of x was, I'm kind of looking around at the previous problems. What was f of x? 3, without having to scroll back up to the top. All right, so those two added together and then multiplied by the h of the limit as x approaches c of h of x, which was 4. All right, so I have 4 times 9. frozen, and that is 36. All right, this one looks cool. So this one's having us, I'm going to square after I take the limit, and then the denominator, we just have a 4, all right? And then it's minus the limit as x approaches c of g of x. So up top, I'm going to have the limit as x approaches c of f of x, which we know is 3, and then we square that. So we're going to square afterwards, and then the denominator is just going to be 4 minus, and then the g of x was -2. They like doing that to us, don't they? All right, and so my numerator is 9, and my denominator is 6. And then, of course, you can go a little bit more. A little note here, on the AP exam, they don't care if you simplify stuff or not. All right, you can leave it completely not simplified. You'll see later what I'm talking about, and it's going to be some nasty looking stuff, and you can leave it just like that. All right, okay. All right, so that's it for example 2, and we're going to put 3 on the same video. I already broke it apart. This is the craziest looking thing I've ever seen. And all the information we need is right here, so that's good. So I've got a constant multiple and then another multiple. So 2 limits multiplied together times 2 minus a cube root of a limit inside there, and then 2 times a limit that has been squared. So make sure we square before we multiply by 2. Yes. All right, so here we go. I'm doing all the substitutions. So I've got 2 times the limit as x approaches c of f of x, we are told is 8. Do that in a minute. And then the limit as x approaches c of g of x is -4. All right, that takes care of all of that. And I'm waiting on the lag. And then I've got the cube root. And if they're kind, that was the f of x, was 8. Good, that's something we can take the cube root of. And then 2 times the limit as x approaches c of g of x is -4. And we're going to square that, though, so be careful there. Make sure you're using parentheses when you're squaring, if you're relying on your calculator to square negative numbers. All right, so there we are. The lag drives me nuts, and it only does it when I start recording. All right, so here we go. What do we got here? We've got 2 times 8, which is 16. 16 times -4 is -64. Mm-hmm. All right, minus the cube root of 8, which is 2. All right, and this is going to be addition because this is going to be positive 16. 16 times 2 is 32. Okay, that works out nicely. And then we've got -64 minus 2, so -66 plus 32. All right, so that gets us to -34. Okay, all right, done.